Okay guys, last notes video here. I'm going to start at number 15 at the top. 4c squared minus 5d squared. Okay, so remember the first thing we want to check for is it a difference? Yes, it's being subtracted, so it is a difference. So the next thing is, are they squares? Okay, well this first one looks fine. Square root of 4 is 2, square root of c squared is c. But square root of 5, okay? 5 is not a square. There's no whole number that we can square and get 5. So I'm not going to be able to find the pretty square root of this one. So since this one is not a square, or I should say not a perfect square, number 15 is prime. Okay? We're only going to be able to factor these if both of the things are true. If it's a difference and both terms are perfect squares, then we can factor them. Okay, but 15 is prime because we are not able to factor it the way we were, oops, sorry, just kidding, come back, the way we did the others on the other side. Okay, and then I want to look at 17 and 19 as well, because what you'll notice here is that the exponents are different. So far up to this point, any variable that we had an exponent of 2, which made it easy. But sometimes the variables are not, or excuse me, the exponents are not 2. They still are perfect squares if the exponents are even, okay? So let me show you what I mean by that. Number 17, this is a difference, okay? And these actually are both squares. The square root of k to the 6th is k to the 3rd, okay? And you're thinking, all right, how are we supposed to know that? Well, remember that finding the square root means you're looking for what squared, what times itself would give me that as the answer, okay? So if I square k to the 3rd, here's k third squared, okay? Well, that's the same as k to the 3rd times k to the 3rd, and we know that that gives us k to the 6th, okay? So if we squared k to the 3rd, it would give us k to the 6th. Now, the shortcut is, when you square root a variable, just divide the exponent by 2, okay? It's half of that. So if this is k to the 6th, the square root is half that exponent, k to the 3rd. Okay, square root of 16 is 4, so we get k cubed plus 4, k cubed minus 4. All right, let's do one more like that. Number 19 is a difference, so I'm going to see if these are squares. Square root of 121 r to the 6th. Well, the square root of 121 is 11. R to the 6th, again, we just cut that in half. Half of 6 is 3, so we get r to the 3, or r cubed. Okay. Square root of 1 is just 1. So our answer here is going to be 11r cubed plus 1 times 11r cubed minus 1. Okay. The last thing you're going to see, sometimes we have to take a step before we can factor the difference of squares. Okay, so this goes back to what we did before spring break and what we did last week. We need to look for a GCF first. So really, we should have been doing these problems first, because the first step, instead of immediately going into the square rooting and all that, is we need to factor out a GCF if there is one, a greatest common factor. Okay, so this is going to look like last week's homework. So 2n squared and 72, the greatest factor they have in common is just 2. Okay, so then I divide both of them by 2, that's going to leave me with n squared minus 36. Okay, now that I factored out the GCF, now I can do the difference of squares. Okay, square root of n squared is n, square root of 36 is 6, so this is going to be n plus 6 times n minus 6. But the very first thing we did was factor out the GCF. We can't forget about him. He comes down in the front, and this is our answer. Okay. So again, first step was to factor out the GCF. Okay. Then we factor the difference of squares. And then just don't forget the GCF. It's got to come down there and be in the front of the whole thing in your final answer. So let's do a couple more together. I'm going to look for the greatest common factor of 32 and 18. And again, the biggest number they have in common is just a 2. So the 2 is my GCF, and I'm going to divide both of those by 2. So that gives me 16s squared minus 9u squared. And now I can do the difference of squares. Okay, my GCF comes here. Square root of 16 is 4. Square root of s is s. Sorry, square root of s squared is s. Let me write that step here. Square root this, square root this. This gives me 3u. So 4s plus 3u, 4s minus 3u. Okay. We're going to do 2 more. And again, don't forget that I'm posting this whole entire note sheet completed on Google Classroom as well. So if you want, you can go through and do all the problems we didn't do and then check your answers there if you need some extra examples. All right, 25. I'm going to factor out the GCF. 24 and 54 both have a factor of 6. 24 divided by 6 leaves me 4a squared minus 54 divided by 6 is 9b squared. So I'm going to take the square root here since they're differences. That's 2a, 3b. So we've got 6 times 2a plus 3b times 2a minus 3b. Okay. Let's do one more. Okay. 80 and 125 both have a factor of 5, but also, let me redo this. Leave a little space. Notice they both have n's, okay? So I can factor out n, and then I'm going to use the smaller of the two exponents. So n squared is also part of my GCF. Okay, so I didn't leave much room, but I'm going to divide by 5n squared. 5n squared. So remember that when it's the same on top and bottom, those are going to cancel. But when the top number is bigger, we just subtract our exponents. So this is going to leave me with 16n squared minus 25. Okay, so we factored our GCF, and that puts us here. Now we're going to take the square root. We get 4n and 5. So our final answer at the bottom is 5n squared times 4n plus 5, 4n minus 5. Okay? All right, guys, so I know that was a lot. Remember, you don't just have to watch this video once and then try the assignment, okay? Watch it, work through it, look at it again. If you need some more examples, I'm going to post the assignment the same way. I'm going to post the quizzes, and I'm going to give you 3 chances to take it, okay? So if it were me, I would work through the notes once or twice, watch the video, try the quizzes, and if I realize I don't understand all of it, go back and try the notes again. Also, if you need an additional resource, I'll post some extra videos. Just let me know what you guys need. I'm attaching a homework page. Okay, not a homework page, just kidding. It says homework, but it's just practice, okay? So it looks like a homework worksheet, but it's just for extra practice. So if you're wanting to work through some of these problems on your own, you can either print that off or write those problems down, and then I'm posting the key to that as well on Google Classroom, okay? Let me know what you guys need from me, and I will talk to you soon.